we do that, we'll solve to see what the number of hours would be, but we do have to define our variables. So let x equal the number of hours. Let h, whatever you want, but you have to define your variables. All right, so we have park 1 and park 2. Now you don't have to do it precisely this way, but some sort of organizational strategy is important. All right, one park has an entrance fee of $8. You're paying that no matter what. Plus $2 for every hour. $2 for every hour. So 2x. The other park has an entrance fee of $2, so flat rate of $2, you're paying that no matter what, and you're paying $5 for every hour. So 5x. All right, if things are going to play out properly, the way the question is asking, these two numbers would have to be equal to one another. All right, so I'm going to solve for the value of x. I'm going to subtract off the 2x. I'm going to subtract off the 2. I like doing it in one shot. You could do it separately if you want. You get 3x on the right, you get a 6 on the left. So I'll write 6 equals 3x. Divide both sides by 3 to get the value of x, which would be 2. So 2 hours. Bless you. Yeah, so you make a final statement based on the context of the problem. Right? It doesn't have to be in a complete sentence because I'm not going to have the attention span to handle that anyway. So just the number, including the appropriate units, right? In this case, hours. Now, the last type of word problem that you're going to focus on, because there were some geometry problems that weren't too crazy in the practice set, but you didn't really touch on consecutive integer problems. They're not difficult. It's just the initial setup is different. All right, it says find 3 consecutive integers whose sum is 300. Now, the important thing is you have to know what an integer is, all right, and you have to know what it means to be consecutive. Consecutive means one after the other, if you didn't know. Let me get my pen back on. I gotta move this over here. All right, one directly after the other. All right, one directly after the other. So if I'm defining my variables, I got to account for 3 different values. So I'm going to let x equal the first integer. I need to come up with 3 integers. So I need the second and the third. But I need an algebraic expression that represents the second integer. How do I get from one number to the number directly after it? How do I get from the number 2 to the number 3?
Plus 1.
Plus 1. So to get from x to the number directly after it, I would do x plus 1. All right. So I went from 2 to 3. How do I get from 3 to 4?
Plus 2.
Minus.
Well, plus another 1, right? But in total, it would be plus 2. So if I'm starting with x,
Wouldn't it be minus 1?
you could do that too,
Okay.
because that would make x minus 1 the first integer, but you'd have to be careful about how you define things, right? Because if you call x minus 1 the third integer consecutively, that technically wouldn't be correct. All right. So their sum has to be 300. Sum is another name for addition, exactly. So add them up. All right, so this is what I meant when I said it's pretty much the same, except the setup is a little bit different. Because once you get to this part, it's just solving an equation. All right, so combine your like terms. I get 3x plus 4. 3, yeah. Equals 3 hundo. So I'm going to subtract off the 3. So 3x equals 297. All right, so I don't really have room to show the division steps, so I'll just show the result. X is equal to what? 99. All right, so now I just have to state what my final answer is. Find 3 consecutive integers. Well, I only found 1, so I got to state what they all are. All right, but that's easy because I don't need like a statement like I had for the last question. I'm just going to tuck my answers in right here. 99, 100, and 101. Now, I'm also going to box this. It's very important that you draw attention to this as your final answer, because when people are reviewing your work, I'm thinking in terms of the regions, because I have an open mind. You know, I'll look all over your paper for the answer. I'll look on other people's papers for your answer. You know, like I'll look on the wall. I'll try to find your answer anywhere. All right. A lot of that was an exaggeration. All right. But the bottom line is, if your answer is somewhere on the paper, odds are I'm going to find it. All right. The regions people, they're not as lenient when it comes to that. They don't allow us to score it that way. All right. So draw attention to your final answer, because the brain kind of takes the grader to the lower right-hand side of the paper looking for the answer, not necessarily going to think to go back to the upper left to try to find the answer. All right, so if you put your answer somewhere other than the end of the problem, make sure you box it, clearly identify it. All right. Number 2 and number 3, I'm just going to do the setup, because like I said before, once you have the setup, it takes off from there. All right. So, I mean, I didn't say that, but I said words that kind of meant the same thing. 3 times the smallest of 3 consecutive even integers. All right. So I'm always gonna start with the same thing. Let x equal the first integer. And you could take liberties with abbreviations. First int. With me, again, it's fine. The regions, write it out, because I know you don't mean interception. All right. Now it's consecutive even integers. So let's say, for example, I'm starting at the number 2. How do I get to the next higher consecutive even integer? Plus 2. So that's my second. Now there's three of them. So how do I get to the next one? Plus 4 in total from the original value. All right, so we have our let statements. I'd like to think that you're probably not going to forget to write these let statements, because they're more crucial for this kind of problem than they were for the number of hours spent at renting bikes at a park. All right. Now, 3 times, so the context of the problem is important, 3 times the smallest, so 3x, right? Is means equals 6 more than twice the largest, so 2 times x plus 4. All right, more than, you could put the 6 plus anywhere. All right, you could do the x plus 4, 2 times x plus 4 and then the plus 6, or you could do the 6 plus the 2 times x plus 4 like I did. All right, it's when you have is 6 less than. All right, you got to be careful about where you put the 6, because addition's commutative, but subtraction is not. All right, so then at this point you would take it away, you distribute and solve. So let's take a look at number 3, and then I'll let you loose. find 4 consecutive odd integers. So let x equal the first integer. All right, now I'm at, let's say, the number 3. I want to get to the next consecutive odd integer. How do I get there? Add 2. Yeah, if I'm at 3 and I want to get to 5, I got to add 2. And then 7, I'm going to add 2 again. Then 9, I'm going to add 2 again. All right? So it's still the same relationship. Regardless of whether you're dealing with consecutive even or consecutive odd, you're still adding 2 each time. All right? So that might take a little of the guesswork out, which is generally a good thing. This time we have 4 consecutive even integers, so we have to account for that. So that the sum of the first 3, so,
Aren't those consecutive odd integers?
oh, I'm sorry, consecutive odd integers, I misspoke.
You've added like even numbers.
Yeah, because every odd integer is separated by 2. So if you're going to go from 3 to 5 to 7 to 9, you're adding 2 every time. All right. So the sum of the first 3 integers, x plus x plus 2 plus x plus 4 exceeds the 4th by 18, which means is more than the 4th value by a total of 18. What do you think that's going to be represented as?
Greater than sign?
You could involve a greater than sign, but we could actually do it without a greater than sign. We could actually get through this just using an equation. If I tell you that my age is more than your age by 18, and I give you my age, how can we figure out your age? Subtract, right? Right? So it exceeds the 4th by 18, so couldn't we just do a quick minus 18? And that would equal the 4th value? All right, the language is a little weird, but it's definitely manageable if you consider it. All right, but that's the thing. I took a situation here that didn't make any real sense. You know, like I didn't get the rousing response that I get for some other questions, and I took it and I contextualized it in a way that made sense to me. All right, we're talking about ages. People can relate to ages. You could relate to heights. You could relate to lengths and things like that. Relating to consecutive integers, not quite.
Could you do, like, for the second one, x plus 6 plus 18?
X plus 6 plus, yes, you could. Yeah, another way to do it would have been to take the x plus 6 and add 18 to that to make the x plus 6 equal the 18. That, if you want to use the same analogy, that would be saying the same thing as my age, I know my age exceeds yours by 18. Let's start with your age. You know, like if we're working off of your age, how can we figure out my age? Take your age and add 18 to it. All right, so that's the analogy that will work in that context. All right.